Okay. Okay, so if we take a look at 43, 43 had us analyzing this table of data. The table of data is what you need as you're given, so you should be writing it down. So our data that they gave us is we have households, and we have, so this is our column of information. We have total households. We have households with PCs, and we have households with internet access. Okay, then we have the data they've collected is from 1997 and 1998. The total households in 1997 was 100, in 1998 was 101. The total households with PCs was 44 in 97 and 48 in 98. And then with internet access is 21 in 97 and 27 in 98. So here is our data. All right. So it says in 43, they want us to look at in 1997. So we're focusing on 1997 for number 8 or for number 43. What is a fraction of households with PCs? So we're looking at this data, households with PCs. Are you cool with what they're asking for? All right, and Frankie, they want a fraction of households with PCs. All right, so a fraction, Frankie, means that our numerator is how many have PCs, and our denominator is how many total households. So, Frankie, how many households in 1997 had PCs? So 44. How many total households were they surveying? No. 48 is the number of households that have PCs in 1998. How many total number of households? We're dealing just with 1997. 100. Because that's the total households in 1997. Do you see that? So it's really important that you understand the data that you're given in a graph or a table or a picture, and then you understand the data that you need from it to accomplish what you're looking for. So this 44 is the number with PCs in 1997. That 100, your denominator is always the total that you are counting from. Our total in 1997. So you can't just grab data randomly. You have to pay attention to the data that you're grabbing from the table. Are you cool? All right, and then we would simplify that. 44 is divisible by 4. It's also divisible, 100 is divisible by 4. So the 44 becomes an 11. The 100 becomes a 25. So this is 11 out of 25. When you're dividing out common factors, please make sure that you are crossing off the original number and you're writing down what you have left when you divide out the common factor. That's very, very, very important that you're crossing that 44 off and you're writing 11 because you divided a 4 out of 44. You cross off the 100 because you're dividing that by 4 and you get 25. Frankie, does that help you? Awesome. What else can I do? Kira? 33? Awesome. So 33 said, I have 56 times P times Q over 7 times, how about 56, not 5? Over 7 times P times Q. Is this one you're talking about? Okay. So I'm going to rewrite this. I just like to kind of spread them out just so I can see what I have. PQ over 7PQ. All right, well, I always start with my numbers. You do have to know your multiplication tables. 56 is divisible by 7, so 56 times 8 is 7. So I can divide out a common factor of 7. 7 divided by 7 is 1. 56 divided by 7 leaves my 8. All right, so I'm just going to kind of circle those real lightly because I know that I have those left. If I look at my p's, well, I have one p in the numerator, I have one in the denominator. They both cancel each other out or divide out, so now I have those p's become ones. Same thing with the q's. I have one q in my numerator that's going to divide out with one q in my denominator. So what I have left is 8 times 1 times 1, which is simply 8, and 1 times 1 times 1, which is 1, or just 8. Does that help you? Awesome. Oh, okay. But you showed crossing it off. Okay. It's okay. We all make mistakes. Trust me. I make them all the time. Romano? 21. So 21 said, I have 40ab squared divided by 5ab. Is this the one you're talking about? You wrote it wrong. I mean, unless your book was different, sometimes we have different, sometimes I randomly would get like a variation of book. Is that the only time you've seen of the different numbers?
No, just in this one, the data and the graph is different. There's the exact same the question.
Oh, so your book might just have a variation of things. Is your book here in school?
No, I have one that was here in school, and I have another copy at home.
I would take your book here at school home with you and compare them, just to see, because I have run into that. Okay, do you want me to do yours? Okay, so what does yours say? Uh-huh. Okay, so if I did your problem here, okay, what common factor, well, let me write this out. So I have 20 times A times B over 5 times A times B. What common factor do 20 and 5 have? 5. So when I divide 20 by 5, what do I get? 4. When I divide 5 by 5, what do I get? Excellent. What else do they have in common? All right, so I'm going to cancel out or divide out an A out of both the numerator and the denominator and a B out of both. So what's left when I multiply? What's everything that's left? Pardon me? 4B or 4B over 1, right? Yep, that's your answer. Did you get that right? Awesome. Okay. Are there any other questions? Okay, put this away, get your notes out. So we're changing things up just a little bit in what we are doing in this next section. All right, we are going to jump into 4.5. It's a little bit of a change up from what we've been doing. This is a problem solving section. All right, and the method that we are, the strategy that we are going to be looking at. Sometimes in the book, this book, they give us these problem solving where we focus on a particular strategy. So these are the kinds of problems that they're story problems, but you're not writing an equation necessarily for them. Sometimes you're just kind of thinking outside the box of how you can organize your data and do something differently. All right. So the strategy that we are talking about that I want you focusing on today is account for all possibilities. That's the strategy that we want to talk about. All right, so let me kind of take a step back and talk about different strategies. All right, so when you are taking the high school placement test, when you are taking the ACT, all right, and you come across a story problem, you've got to kind of go into your brain, you've got to read the whole problem, and you've got to say to yourself, okay, how am I going to solve this? What's the best way? Not all problems require you doing a game plan. Because game plans are when you're writing equations. And for some of these, you can't write an equation. Or maybe you can't see what equation to write. So you're going to think in a different way to be like, okay, how can I solve this? So this is a list. This is in your book. These are a list of all different strategies that you can use to solve a math problem. Draw a diagram. Sometimes just drawing something can help you figure out a problem, right? Drawing a picture of something. Looking for a pattern. All right, when we look at, one of the things on the high school placement test is going to be lists of numbers. All right, and you've got to figure what the pattern of the list of numbers is. For example, my list of numbers is 1, 3, 5, 7. What's the pattern that I have in that list of numbers? 1, 3, 5, 7. And I said to you, okay, what are the next two numbers on that list? You have to look for a pattern. What's that pattern that I have? What am I counting by? 1, 3, 5, 7. What's my pattern? Audrey? You're counting by your odd numbers, right? So if I have 1, 3, 5, 7, what's the next one in line? 9. All right? If I have 1, then I have 4, then I have 9. Well, 4 is a square. It's 2 squared. 9 is 3 squared. The next one would be 4 squared, which is 16. So you're looking for a pattern. All right? Making a model. Making a table. Creating a table of data. That's one way you can. All right? Some of them are writing an equation. Writing a proportion. Working backwards. How many of you guys have ever been where you're like, okay, at 6 o'clock tonight, I'm going over to my friend's house to spend the night. But you've got a bunch of things you have to do throughout the day. All right? You've got to work backwards of when you need to get up in the morning. How about if you guys have ever had that happen, where you have a bunch of stuff you have to do in the day, but you've got to be somewhere at the end of the day. So you're like, okay, how late can I possibly sleep in to be able to get all this stuff done? Well, you're going to work backwards. You want to be there at 6 o'clock. You have to be at your house. It takes 15 minutes to get there. Your mom and dad have to be back at the house at 5:45. Okay. It's going to take you X amount of time to get all this stuff done. So you back up and say, okay, I can sleep in until 11:30 and get all my stuff done and be there by 6. That's not something you're going to write an equation for. That's something you're going to work backwards from what time you want to be somewhere. Okay? So these are all different strategies that you can use to solve a problem. We are focusing on account for all possibilities. Okay, now that might mean drawing a diagram to help you do that. Could be drawing a picture to help you do that, okay? So, how many of you guys have ever lost something? Okay? What's the first thing your mom and dad say to you when you've lost something? Kira? Look in your room. What else have they said to you? Christiana? Stay calm, for sure. Addison? Retrace your steps. Where have you been? Where were you in the house? Were you, say, in the family room, right? You're accounting for all the possibilities of where you could have been. Can you guys see that? Okay. So I'm going to show you a situation. You may solve this in any way you can. You need to be organized with your data, very organized with your data. We have to be able to read it and follow it, and then you're going to answer the question. Are you guys good? Okay. So how you may organize it might be different than somebody else might organize it. All right, so let's read through what we have here. Somebody read this for us. Michaela? Okay, so let's think about that for a second. How many people are in each picture? How many people are in each picture? Jack? 2. So that's you and your friend. All right, so let's think about in this room. If you guys all want to take a picture with everybody in this room, you're only going to take it once, right? So Romano's going to take a picture with Aaron. Then Romano's going to take a picture with Jack. Then Romano's going to take a picture with Dominic. okay? You can only take one picture with each. Do you guys understand? So there's not going to be two pictures of Jack and Romano. There's just going to be one. Do you guys understand? Okay, that's the situation. You want to know how many pictures are going to be taken. Go. So write down the givens and then figure out how you want to solve this. You can work with people by you. Be organized. Talking with people. All right, you don't have to only figure out how you want to do it on your own. Work together. All right, be smart about how you want to organize this. Take a moment to do it. You might start organizing it and be like, oh, that's not going to work, and you're going to erase it. All right, think about drawing a picture. Think about using a table, maybe, to help you. Just try and be organized. And I am going to have you guys share. All right, so it has to be legible. And remember, in the end, you want to know how many pictures do they need to take. Yes. Okay, so you're going to take a picture with Aaron. Then you're going to take a picture with Jack, and then you're going to take a picture with Addison, and then you're going to take a picture with Dominic. So you're going to take a picture with everybody in this room. But once you've taken a picture with Erin, because Erin needs to take a picture with you when it comes to her turn to take a picture. So think about you being like, okay, it's my turn to go in the booth. You like a picture booth? So everyone's going to stay in line. You're going to be like, okay, you're going to go in, and each of you individually are just going to go and take a picture with you. You're done. So it's Erin's turn. Does she need to take a picture with you? Hasn't she already taken a picture with you? Right? So when it's her turn, she's already taken a picture with you, hasn't she? Okay, so she doesn't have to take a picture with you anymore because you already have one. Does that make sense? Okay. So this is simply not just a math problem. You're not just going to all of a sudden be like, oh, I have 1, 2, 3, 4, 5, 6, 7 people. I get to multiply that by 2, and that's going to be my answer. That's not how this works. That's not how this works. All right, so you need to think this through. If Frankie takes a picture with Michaela, when it's time for Michaela to take pictures with people, she's not going to take one with Frankie. Because Frankie and her already have a picture when Frankie went through. Do you guys understand? So it's not just a matter of multiplying by 2 here. That's not how this is going to work. All right, so be organized with your work. If you're not sure, talk to someone sitting by you. Think of this from a functional standpoint. Start with one person. Layla's going to take a picture with everybody in the room. Then go to Pierre. Figure out who he still needs to take a picture with, etc. Does that make sense to you guys? Terry, you think you're done? Okay. Are you done? Okay. No. 21 is not the answer. For any of you that get down to 21, it's not the answer. It's too small. Oh, I lied. 21 is the answer. I was looking at a different one. Thank you. Yeah. One for them. You're sure talk to somebody. Look around, talk to people. See how you guys. I want you guys to learn from other people. All right, because there are different ways to think about things. It's really important that you learn how to start something. All right, so my suggestion is, if you're not sure what to do, one good way to do this is start with a person. Start with Mandy. Show her taking a picture with everybody. Somehow organize it that way. Then move on to the next one. But recognize once Mandy is taking a picture with Jim, Jim doesn't need to take a picture with Mandy because they already have it. So start with one person. No, that's not true. God bless you. So I need you guys to really think through how this works. So think of this logically. Put yourself in the position that you're going to get pictures taken and how it's going to work. I want you to ask each other questions. You guys can talk. I'm talking this through, talk it through. And when we start showing you guys the different ways people do it, I want you looking at how people organize it. Because you might be like, oh God, why didn't I think of that to do it that way? So now you have a way that you can organize your work if you ever have to do this again. All right, because there is more than one way to do some of these and organize it. And different people's brains kind of think of different ways to organize it, and they're all really good ways to do it. to show us what they did and how they organized it. All right, Layla, come on. And I'm going to have a couple people. Let me just zoom out a little bit here. All right, I'll leave you to kind of center it and zoom out as you need to. You're going to explain what you did.
Okay. So,
If you want to zoom out, you can. Okay. So it's the bottom. No, not that one. Next right front. Right here. Okay, so you guys listen.
so I made a table and I said people and then pictures on the right. And then I wrote all the names right here. And then Mandy took a picture with all the people under her. So then Jim, when I was writing names for Jim, he didn't have to take a picture with Mandy, so I just wrote all the names under Jim. And then same thing with Keisha, and then Darren, Lynn, and Chris, and Jen.
First of all, how many of you guys can follow what she did, like her organization? Okay, so what Layla found is she started with Mandy, and Mandy took a picture with everyone. Once Mandy took a picture with all of those people, when those people go to take a picture, they're not taking a picture with Mandy. So Mandy gets dropped off the list. So if you look at Jim's list, it has everybody on there but him and Mandy. All right, Keisha's gets dropped, Jim and Mandy get dropped off of Keisha's because Jim and Mandy already took a picture with Keisha. How many of you guys can kind of see how this works? All right, and then you add them all up. So, how many of you guys like what she did and it was really easy to follow? Okay, awesome. Who did something different and got the same answer? Mateo, come on. Thank you, sweetie. I want you guys paying attention to how people organize their stuff so you have different ideas.
I don't remember how I zoomed.
Where are you here? Okay, so that's okay, go ahead.
My handwriting's really messy, but so I started with Jen because I ran out of room over here. So what I did was the person that is before, so Jen has everybody, but then Mandy gets rid of Jen because the person before Mandy, which is Jen, already took a picture with Mandy, and then so with Jim, Jim already took a picture with Mandy and Jen, so they're not on his list. And then Keisha already did Jim, Mandy, and Jen, and Darren did everybody, like Keisha, Jim, Mandy, and Jen, and Lynn, I don't know how to pronounce it, did Darren, Keisha, Jim, Mandy, and Jen, and then Chris already did everybody, so he didn't do anybody.
Okay, so I want you to leave this up here for a second because I really like, and I want to say the same thing about yours as well. So anybody that organized it this way, the one thing I want to commend both of you guys for on this is your way of organizing it. The nice thing I like about what Layla and Mateo did is their list, they were very careful, I think, if I'm looking at this right, they were very careful when they listed the names across and then put the names on their list from there, that they're the same order. All right, so he has Jim, Mandy, he has Jen, Mandy, Jim, Keisha, and it kind of goes from there. And when he puts his letters up here for who they took a picture of, the order that he wrote them is the same order for each of them. He doesn't change the order. So he knows all he needs to do. He has Mandy first, and then Jim, which is the order in which he wrote it across the top. So he can very easily just drop off Mandy when he gets to Mandy. He can drop off, the next one down, so he can be very organized with who he drops off, right? If it's organized and it's not random, you're going to be like, oh, this is easy. I just keep dropping off that first person on the list to go to the next one. Does that make sense? All right, so being organized is super, super important when you are working in math or anything logical that you're trying to figure out. Awesome. Who did something different other than listing them that way, kind of like in a table form? You want to come show us?
It was kind of like oil, but without like
Show us. Because I did see people doing different things, and I want you guys to show all the different ways so we can see different ways we might choose to do it. Okay, so you did something similar, where you list them all. How many of you guys did similar to what Frankie has here and what the other two did? All All right, that was a good way to do it, isn't it? Kind of listing them. All right, Jack, I think you did something a little different. Can I see what you did? Because I think, Christiana, you did something similar to this. So explain how you did it. Obviously, we're not going to be able to show all of them on there, but how did you decide to organize it?
I wrote down, I organized it into groups, as in, this is Mandy's group, the first 6, and then Jim's group down here, and so on. And for each one, it has one less person than the other one, so that each time you move on to a different group, there's already a picture of the first person and one of the other ones.
How many of you guys follow what he did? Right? This is nice. Who did something like this? Awesome. This is going to help me with something. I'm going to freeze this, and I'm going to go up to the board. Hang on one second. You can take this with you. I'm just going to do that for now, and this will help me. Okay. Math is all about patterns. Like, all about patterns. And that's how we've come up, whoever was really smart people that came up with all this math stuff that we're doing, they figured out patterns as they've gone through time. All right? The pattern that I want to show you is, how many people started this? Like, how many people were there in the list of people that want to take pictures? How many total people did we have? Aaron? All right. So we had 7 total people. All right. Once we started this list, and I like this list because this is going to help me with what I'm trying to show you. Once I start with this list, how many people did Mandy take a picture with? How many people did Mandy take a picture with? Alex? 6 people. How many people did Jim take a picture with? Caleb? 5. Without even having to finish that list, how many people will Darren take a picture with? Without even looking at that list, how many people will he take a picture with? 4. My next one is Lynn. How many people is Lynn going to take a picture with? Jen or Vincent? 3. Who's next on my list? Lynn, Chris. How many people is Chris going to take a picture with? Leila? 2. Chris, Jen. How many people is Jen going to take a picture with? Frankie? 1. And my last one is Darren, right? No, Keisha. Did I do Keisha yet? I skipped Keisha. Here's Keisha. How many people is Keisha going to take a picture with? Alex? 0. Can you guys see the pattern? Right? So here, I can just add all these up, and I get 21. So let me ask you guys something. If we had 10 people, let's say this is my number person. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Knowing this pattern, how many people is the first person going to take a picture with? Aaron? 9. How many people is the second person going to take a picture with? Christiana? 8. Can you kind of see what happened here? I don't, now that I know the pattern to this, I didn't even now need to list out everything, now that I knew the pattern. Does that make sense to you guys? So understanding the pattern, once we got to here, and maybe even to Darren, you probably could have stopped your list and said, I see a pattern. So once we got to Darren, I would have allowed you to say, you know what, I see a pattern in this. My pattern is I'm going to decrease by 1 each time, and you could simply have written all this down to get your answer, because you found the pattern. Does that make sense to you guys? Okay. Yes. No, because we're going to test. All right, thank you. You guys can go. Nice job, you guys. Thank you for sharing.